Okay, hey guys. Today we are going to have just a quick physics lesson to go over a small but important topic. First of all, let's look at this far side. Far side is one of my favorites, as you may already know. So you see this guy talking to these two over here. I told you guys to slow down and take it easy, or something like this would happen. So what happened? Looks like they have a catapult. Look at this guy. Oh my gosh. Okay, so this is our reminder to slow down and take it easy when we are talking about acceleration, because there is a really important concept, which is the sign of acceleration, meaning, is it positive? Is it negative? Now, it's normal to want to think that if you have a positive acceleration, that means you're speeding up. And if you're slowing down, then it's a negative acceleration. But guess what? It's not quite that easy. And that's why I put this sign right here, because this is not going to give you the right answer all the time. And that's not how you need to think about it. It feels too easy. And that's because it is. So this one's going to be too easy. Let's think about it this way. Acceleration is a vector, and as a vector, it has direction. Therefore, if you are speeding up and going to the right, that's going to be a positive acceleration. Remember how we talked about velocity? And with velocity, if you go to the right or if you go up, that's just by convention going to be a positive velocity. So that's true for acceleration too. If you're speeding up and going to the right, then that's positive. If you're speeding up and going up, that's also positive. But let's look at these other examples for when it gets a little bit more complicated. Okay, here we have, look at this part first. Look at these arrows, and remember that the arrows mean velocity. It's a velocity vector, and a larger or longer arrow means that there's more velocity. Okay, so when we look at this object here, this is an object that is moving to the right because the arrows are this way. And we know that it's speeding up because the arrows are increasing in length. So this is moving to the right and speeding up. So therefore, the acceleration is going to be positive. And you'll remember that when you do a velocity time graph, acceleration is the slope. So a positive slope goes upward like that, like you're going uphill. Okay, so this is positive. Easy peasy. We've got that, right? Now, let's look at this one. Before you say you've got it, really pay attention to this one. Now, the arrows are going this way, so I'm going to start looking over here first. We start here, and there's a long arrow, and then the next dot, and then there's a shorter arrow. So this is going to the left, but it's slowing down. What does that look like on a velocity time graph? So here's velocity, here's time. Now we have to think about this for a minute so that we can get it right. Okay, on the x-axis, we have time. Now, time always moves in a forward direction, right? We cannot go backwards in time unless you're on that movie. But anyway, time always goes this way. So we're going to start here. And we start with a negative velocity because we're going to the left. So anytime it's going to the left or going down, the velocity vector is going to be negative. So that's why we start here below zero, because remember this line is zero. Now, it said we were slowing down and going to the left. So slowing down means that the velocity is getting closer and closer to zero as we increase the time. Because when the velocity is zero, that means we're stopped. So we start out at this negative velocity because we're going to the left. We're still in negative velocity here, meaning we're still going to the left, but we're slowing down. But look at the slope. The slope is still going uphill that means the acceleration is going to be positive. Positive slope, positive acceleration. Now, does that make sense? Because remember, the object is moving to the left, but it's slowing down. I kind of think it makes sense because if you start here, even though you're moving to the left, you're slowing down. In my mind, it feels like that means something is pulling it this way because we're slowing down. And so it's almost the same as speeding up and going to the right. It's just slowing down and going to the left right now, but it seems like eventually it will end up going to the right and then end up speeding up and going to the right. So the acceleration is that way, is positive. Okay, another way to think about it, if that is too complicated, because that is pretty complicated. Here's another way to think about it. If the object is speeding up, I'm going to write this down because this is important. If the object is speeding up, the velocity vector and the acceleration vector point in the same direction. Maybe that's a better way to remember it if that helps you. If the object is slowing down, then the velocity vector is the opposite direction as the acceleration vector. So that's true all the time when the object is slowing down. Let's keep doing these and see if we can use that to help us figure this out. Okay, we were on the third one. The object in this example is moving to the right and slowing down. So we're moving to the right. We start out fast and then the velocity gets smaller. If we're moving to the right, that means the velocity vector is positive. So we start out with a high velocity, so it's far away from zero, but it's on the positive side. It's up from zero. If we're slowing down, that means we're getting closer to that baseline of velocity zero. So we're going like this. And as time goes on, we might eventually slow down completely till we reach a velocity of zero. A couple ways to think about acceleration here. You can think, well, acceleration is the slope. The slope is going downward, meaning if I put a ball or a coin right here, it would fall down. It's a negative slope, therefore the acceleration is negative. Or you can use that rule. Is the object speeding up or slowing down? In this case, it's slowing down. So even though the velocity is positive, the acceleration will be negative because their signs will be opposite. Okay, let's do the last one and hopefully this will stick in your brain. In this situation, the object is moving to the left, so the velocity is less than zero, and it's speeding up. Let's look at what the velocity time graph will look like. The velocity is moving to the left, so the velocity is negative, meaning it's below zero, below the baseline, and it's speeding up, so it's increasing in magnitude. It's getting farther away from zero. So the velocity is going to be negative. Now, what about the acceleration? To me, I kind of look at this, I know that time means it's always going that way. So if I put a ball or a coin here, the slope is negative. The ball or coin would fall down. So the acceleration is negative. Let's use the other rule. If this is speeding up, then the velocity vector and the acceleration vector go in the same direction. In this case, they're both negative. Cool. So as you can see, it's not as easy as things that are speeding up have a positive acceleration and things that are slowing down have a negative. It's not that easy. You have to think about it a little bit deeper because you have to take into account the direction or the slope of the line. When it comes to acceleration, it's a vector. You're going to have to think about the sign. Let's do this stop to think and make sure that we know this inside and out. Here we have, in this example, an elevator is moving downward. Now for me, it's hard to think of up and down as positive and negative velocity. So if you want to think about this as an object that's moving to the left, that's exactly the same as what we were doing before. But in this situation, the elevator is moving downward. It is slowing down. Does that mean it's getting closer to or farther away from the baseline of 0? It's slowing down as it approaches the ground floor. Here's the question. Adapt the information we just learned to determine which of the following velocity graphs, so these are all velocity time graphs, best represents the motion of the elevator. So first we need to decide, is the velocity positive or negative? So since it's moving downward, by convention, it's going to be negative or below the baseline of 0. So I can automatically eliminate this one and eliminate this one because those are both positive velocities. Now it tells us that the object is slowing down. Here's the baseline of 0. This means 0 velocity. Is it getting closer to it or is it getting farther away? Well, it's getting closer to it because we're approaching the ground floor and we want to stop. Ideally at the ground floor, the velocity is 0. It's not some huge number right there and we have to jump off. That would be scary. This velocity time graph shows the object getting closer to 0. So that's the one we want. So we know it's not this. So now we can eliminate this. Sweet. Okay, what if we took this to the next level and asked what the acceleration was? I already know that the velocity is negative. I can also think about that as having a leftward vector. I'm going to erase the negative if I put that arrow that way because that is like a double negative in a sentence. Doesn't make sense. So what about the acceleration? I know the question doesn't ask this, but we're smarter than the question. We can figure it out. To me, all I know is I see it going uphill. That's a positive acceleration. Or to the right. But what if we use the rule? This object is slowing down, so the velocity vector and the acceleration and the acceleration vector are going to be opposites. Are these opposites? Yes. We got it right. Yes. We're so smart. We're smarter than Winnie the Pooh. Or maybe he could figure it out. He just needs to think harder. Okay, let's do one more stop to think, and then we're going to be all done. Okay, this stop to think shows us a velocity time graph. Here's velocity, here's time, of a particle. Particle starts out at some velocity right there at A, and then it looks like the velocity is increasing, it's increasing, it's increasing. It reaches a maximum right there at B. And then the velocity starts to decrease. The velocity here continues to decrease. And then it looks like this object is heading towards the velocity of 0 as we get to D. And the question is, at which labeled point is the magnitude of the acceleration the greatest? Now this is interesting because they're asking the magnitude of the acceleration. When they're saying magnitude, they're saying you don't have to pay any attention to the direction or the vector of acceleration, only when the amount of acceleration is the greatest, the magnitude only. So just the absolute value of that number. Let's take a look. Remember that acceleration is change in velocity over change in time. And acceleration is also the slope of a velocity time graph. So there are a couple ways that you could do this. You could sort of eyeball the slope. If I were looking at A, I would say the slope is there. It's your tangential line. You know, it's interesting right here where the slope is actually looks like it's 0 right at that spot. It's still going at some high velocity. That's actually when it reaches its maximum velocity. But it goes from reaching the peak velocity to starting to slow down. So if I were to think about this in terms of what could this be, what kind of analogy would this be? It might be like you're driving along a road and your car is you're driving. During this part, you have the gas on. And then right at B, you take your foot off the gas. and you start to slow down. You're still going to the right, you still have a velocity, but right here at this point, you've already reached your maximum velocity. Maybe you noticed that you were going a little past the speed limit and you let up on the gas. So this is what that means to me. Now here at C, if I were to estimate the slope there, it would look something like that. It's pretty steep. That's kind of like the steepest part of the slide. You're still moving in your car to the right, it looks like, but the slope is the greatest. What does that mean? That means your velocity is actually undergoing the most change per unit time. Here at D, the velocity is not changing very much. The tangent of that line is there. So a couple ways you can think about it. If you draw your little triangle, velocity change in time, and then your tangential line, right here, you're not changing your velocity very much, even though your time distance might be the same, about the same as the one I drew there. That's time on the x-axis. Ooh, another way to think about it is, where is this magnitude, the up and down magnitude, the y compared to the x the greatest? Y compared to the x, not very much there. This one, C, if I took this same unit of time and put it like here, look at my change in y. That's huge. So that means the slope is super steep. Of course, D, that change in y is not very much, or the change in velocity is not very much. So where is the acceleration the greatest? It's wherever the change in velocity is the greatest, or it's wherever the slope is the steepest. Therefore, the answer is C. Easy peasy, right? You guys have got this down. You are done. All right, have a great day. Bye.